Professor UnionKing is a famous mathematician in the world. He has made great contributions in the algebraic geometry. He is the invited speaker of the International Congress of Mathematics held in Helsinki. He also in the major in many aspects of the algebraic geometry, important contributions such as the classification of algebraic manifolds and the conform field theory in the Riemann surface and so on. So let's welcome.
Yeah, thank you very much. I'm very glad and honored to give a talk here. And I'm very sorry I can't speak Chinese. Although I really love the old Chinese classics. And I can read old Chinese literature, but in Japanese way, unfortunately, not Chinese. Pronunciation and grammar are completely different.
You can write.
Somehow, yes, I can write some characters. Okay, so the purpose of my talk is maybe twofold. So I would like to talk about the history of mathematics of 19th century. But the main purpose is not just giving a history of mathematics, but I would like to give you the how some old idea developed to the modern mathematics. So I would like to start first at the complex numbers and theory of equations, and until the theory of Galois theory. So in a sense, the most beautiful and abstract theory of the theory of equations. And then I would like to talk about the elliptic functions and abelian functions, and also the general theory of function of one complex variables, which is also very much related to the theory of equations. And the third topics I'm thinking is talk about the geometry. So in 19th century, people found the non-Euclidean geometry, but not only that, they developed differential geometry, and which was used in physics, especially in general relativity, and that's also very important inventions. And in geometry and algebra, there are deep connections using the group theory. So I think that, and then you have a time. But then I will talk about a little bit about the real analysis. The 2 weeks is very long, but also in some sense very short. So I can't cover the whole topics. But somehow, I would like to emphasize that mathematics is a sort of is always unified. One thing is, as a mathematician, usually we work in the one special field. But still, that one field is related to a completely different field. For example, recently I'm interested in studying the conformal field theory, which is a physical theory of the two-dimensional quantum field theory. But it's related to the geometry in the sense you need to use compact Riemann surfaces. But recently we found that two-dimensional theory is related to the three-dimensional real topological theory. So in that way, that mathematics is always unified in one way. So I really hope that I can deliver some beautiful idea of the old and new mathematics. Okay, so first, let's start with the complex numbers. Do you use this? Same?
No.
No. What do you use?
Yes.
I'm sorry, I'm using the
I
Japanese.
think you can understand.
Yes, but what do you?
We use this one.
No second one. No second. Yeah.
Oh, I see.
Simple.
Simple. So you need not.
Yeah, no,
Yes, I see. Okay. And that, as a complex numbers, just I'm talking about 19th century, but just going back to the 16th century, the first Cardano, he posed the following questions. So you have two numbers, A and B, and the sum of these two numbers is 10, but if you multiply both numbers, you get 40. Then what is A and B? And before Cardano, people said there is no solution. But in some sense, Cardano wrote in his famous book, Ars Magna, that these two numbers is a solution of the quadratic equation. Zero, of course. And you know how to solve that quadratic equation. So the solution is very simple. So you got what is 5 times 5.
60.
What is
60.
60? No, no. 20.
Yeah.
25.
Minus 6.
5?
15.
Oh, yeah,
15.
yeah, 15,
Yeah.
15, yeah. Over.
And at least this is the first time that appeared in mathematical literature that complex number. And actually, Cardano wrote the different notation because at that time there is no such a symbol. So what he wrote is sorry. I didn't bring. I think he wrote in something like 5 plus, then root, and then with a minus 15. This is the first one. And second one is 5 minus root minus, 15. He wrote in this way. And this is a first time. But of course, you know that Cardano is very famous in the sense that he described that how to solve the cubic equation in this famous book. But strange enough that he only considers sort of the real solutions. And only for the quadratic equation, he introduced the complex numbers. And later, his people, Bombieri, developed the theory. And he is probably the first mathematician who really used complex numbers. And also he found very, very strange phenomena about complex numbers. So when he was born, sorry. In my computer I have a data about So Bombieri wrote a book of algebra. 1972. And here he discussed the cubic equation, especially he considered the following equations. And of course, you can easily find one solution. X equal 4 is a solution. Yeah? So cube of 4 is 64 and 16 is 64.
Yeah.
Okay. But on the other hand, in that book, he developed the how to solve the cubic equation in general. So he gave the sort of the general expression of the solution of the equations in the following form: x cubed plus px plus q equals 0. Okay. Yeah, first, please note that usually the cubic equation will have extra terms. But if you change the variable x minus 3, then it reduces to the equation always. You can always choose the second limit term. Okay? So it's enough to consider this equation, especially this is a equation is this type. And how to solve this equation? So what Bombelli and also the Italian old mathematician think in the following way. So just introduce 2 by plus u plus v. Okay. And rewrite this equation in terms of the u and v. Okay, let's do it. It's very simple. Then what do you get? So you have this term, and then we. That's right. Okay. So you can just 3uv plus p times u plus v plus q equals 0. So this is an equation you get. Okay. So at the moment u and v are arbitrary, but now let us pose a condition, one condition, such that this term vanishes. So means that now you assume that uv equal minus p over 3. This is pose condition. Because u and v are arbitrary, it's a 2 parameters, so you can always. That's okay? Then this equation becomes u cubed plus v cubed is minus q. So this is, in a sense, it's a quite clever way, because once you pose these conditions, then automatically that uq plus vq should be minus q. Okay? Then what you get is uq is 7. Okay. Then this you know very well. So it's the same as Cardano's problems. So you have 2 numbers, u cube and v cube. Its sum is minus q. And if it multiplies, then it's minus p cube over 27. So this means that u cube and v cube are solutions of the quadratic equation t cube plus qt minus so this means that to solve the cubic equation, you just need